Welcome to CONQRA. I'm Grant Brown, Managing Director of the CONQRA Company and range of products. I'm here this afternoon to introduce you to some of the range of the products that we have that can also be viewed online, www.conqra.com. This is a range of products specialising in the foundations, which I've been in since probably around the early 90s. I also hold Class 1 and 2 LBP as a licensed building practitioner. We're going to start off with the CONQRA range of raft floor componentry, but as I've said previously, some of the other products, the CONQRA Apache, which is the vapor barrier free control joint for raft type foundations and conventional slabs, and also the original product that I started with, the CONQRA Easy Yakka, which is the precast concrete foundation pad, the principal load bearing element of a timber pile foundation. All those products available separately online on our website. So what I'm really here for now is to introduce you to the Stunna range of componentry, which is the pre-galvanized spaces that hold and form and formulate a polystyrene pod floor. In our range here, the one I'm holding at the moment is the 100 internal, which is probably the most prominent of spacer used in the market, gleaned out of the AS 2870, the Australian standard. However, we also have the 160, which is a very popular one in that standard, and it's quite often used in the living areas of raft floor design, where the live load is less, but we get a bigger grid pattern of 1.8 by 2.4, which is a cost saving in the concrete used in the canals and also the reinforcement, but also a big advantage in the thermal insulation. However, the 100 is always used in the garage in the standalone and is more prominent in the field. The beauty about the CONQRA spacer, quite simply, it forms a canal, it clips and holds the polystyrene pods together as a mat. So the whole system, once installed inside the foundation, becomes a mat that can be pulled, moved around and aligned. But the beauty of this really, and you'll see it in some of the clips and coming through in the video, the Rio sits in the middle. It doesn't have to be tied in the internal canals, it does on the exterior, but preferably it just sits down in the middle and overlaps itself, can't go anywhere during the concrete pour, and gets an even nice flow of concrete coming through the canal. So that's the 100 and the 160 covered. The next one is the internal load bearing canal. Typically 2 bars down the bottom, spaced evenly here, and normally 300 millimeters wide. However, this is 200, but it's a multiple fitting, it can be extended out. It's also used in the free control joint, where often an engineer will put it in where he's putting a saw cut or an expansion joint, and typically look at the engineer's detail on the drawing for that. So that's the internal load bearing canal. The next ones we'll shift into discussing is the external one. Typically a 300 wide rib touching the formwork. Remembering these are pre-galvanized, so when this goes out and touches the formwork, there is no risk of any form of durability, and they're accepted nationwide and have been for at least the last 12 to 15 years. The 300s are standard with 2 bar, but we also have the 400 for a wider canal if needed that carries 3 bars, but it's easy for a contractor to tie a 3rd bar into the 300 canal if he deems it necessary. So that's the standard range of what you see in the field. What's unique about CONQRA is the fact that we use a CAD bender to bend these. They're not injection molded plastic where you're stuck with one simple design. We're talking about a CAD bender that's very versatile and can bend quite a number of shapes, and I'm going to take you through a few of those now. The one that's up on the board here is the CONQRA C-Link internal. What this forms is a typical C-Link that an engineer is looking for in a rib. By doing this here, the contractor places all the C-Links through the floor, forming the mat type grid that we're talking about, and also enables him to place the bottom reinforcement both ways. He also then comes along and simply hooks the top bar up underneath and ties it in position both ways. Can you imagine the saving that this introduces in the field, where if an engineer specifies lengths of C-Link, You run them long ways, longitudinal through the raft, but you have to run them opposing. That means lapping bars, trying to thread bars. This probably has a 70% labour saving. We've just completed a supermarket in West Auckland, estimated time to install D16 up to D24 rods through 3,500 pods. We used 10,000 spaces and we had a 10mm version of this. And I'm going to show you another form of this in 10mm in a second. So this simply replaces the R6 C-Link as we know it. But loads of saving. Most important, the way it forms the rib, stops the pods bunching up during that concrete pour, and considering this is a structural element, that's huge in my opinion. Alright, the C-Link. The next one we go on to is the 4-bar multi-link. This is the same principle, clips the pods apart, 300 wide. If you go into our video under the polyraft section, this is also used in our suspended mid-floor. It carries 4 D16s, 4 D12s, same principle, 2 bars in the bottom, opposing ways, simply place the bars into the canals, overlap them, they don't have to be tied, very user-friendly. Then we thread the 2 bars through the top, opposing each way. Once again, eliminating that need of trying to place a cage one way and another one opposing. So that's the 4-bar structural length. The next one down is a 4 to 6 bar internal. Same thing, 2 bars in the bottom with a 3rd one in the middle. You'll see this in the polyraft system, used extensively over pole-driven floors. Another bar at the top, another bar there, and a 3rd one in the middle. So that's the 4 to 6 bar carrier. The next one down in this range is what we call the CONQRA top bar multi-spreader. Quite simply placed, if a engineer is specifying just 2 bars in a canal, one top, one bottom, that can sit in the bottom. This goes over the top, clips the 2 pods into position, and it can have a choice of 1 bar in the middle or 2 bars either side. Just very user-friendly, and particularly when you're using small bits of polystyrene, the way these spaces clip it together holds it together, particularly during the aggressive form of pumping the floor at the end. Also online is a complete installation of a CONQRA polyraft floor, and have a look at how aggressive it is when a concrete pump is pushing concrete into a canal. The last one down the bottom here is a simple little thing that we use. It's just a 300mm staple. We do make them in 400 and 500 wide. Once again, that's for just clipping the silly little bits of polystyrene that typically I prefer to leave out, but some people think that a wider canal with a lot more concrete is expensive, but the smaller pieces of polystyrene tend to float. This is also used extensively in site cuts, where you see contractors trying to protect a bank, where they've cut a bank down in a platform. They'll put all sorts of things up on the DPM. This is great. You just simply place a piece of timber with a couple of holes in, push them into the bank, gives a lot of wind resistance and everything else. I sell lots of these to people putting down weed stop on the motorway systems, and also particularly for putting DPM on banks. The other one I wanted to show you was a 10mm one of the 4-bar. This was used extensively. It had a step down in it, just in some areas in the Southland Hospital in Invercargill. It's the biggest raft floor to date, 13,500 squares. I did it in conjunction with Fletcher and Arrow. There's a lovely reference on our website from them. So all of this componentry can be bent in R10 as well. So what are we up against? Okay. What we're up against, and is prominent in the market, remembering a lot of engineers specify a canal and a concrete depth at the Rio placement, but they don't do a spacer, and a lot of engineers don't get to the field to see what happens afterwards. So this is the most common form of spacer in the field. It's used widely, mainly because it's supplied by polystyrene suppliers and not engineers. And what happens, it sits at the intersections of the pods. So a pod will sit in here at this intersection, sit in here at this intersection, one here and one here. The Rio is meant to go through here and across, and then get a concrete cover over it. But my terminology of concrete cover is stone over stone gives it its strength. So I've got to ask you in your own right, looking at this, And typically, people don't vibrate the floors. They are meant to. They'll do the edge beams, but not internally. How do stones get over and lap themselves to get the true strength that concrete needs and the Rio cover from that? Also, when I go to the field and I watch these systems in action, the only reliance to hold the pod in place really is the contractor standing on top of the pod, relying on the bar chairs and the mesh to put it on. They move, they bunch. Any engineer that's specifying good strength will surely look at our system, and a lot are now. I suppose our biggest Achilles heel is this is the first time our systems have been online. But anyway, your call. Good quality R6 galvanised or plastic. I know what I think. Right, so at the end of this, just a wrap on it, CONQRA products available nationwide. The R6 galvanised spaces, the CONQRA Easy Yakka, the CONQRA Apache. Please specify with confidence. Any more information, simply email us www.conqra.com. Thank you for your time.